Hello students, today I am going to discuss about design of hollow shaft. We generally observe that the bending stresses and the torsional stresses are zero or negligibly small at the center of the shaft. So we can say when the radius of the shaft increases, the resisting stress due to external bending and the torsional moment also increases. So in resisting the moment, generally the outer layer or the outer fiber of the shaft are more effective. So if we compare both solid shaft or the hollow shaft, so if we compare the solid shaft, generally hollow shaft is more stronger because in hollow shaft the material of the center is removed and it is spreaded to outer radius of the shaft. But generally the diameter of the hollow shaft is more and it requires more space. Hollow shaft is generally made of extrusion process, and the applications of the hollow shaft. The hollow shaft is generally used as the propeller shaft in automobile and axle of railway wagons, or it generally used to provide passage to coolant or the cable in case of drilling or deep hole drilling. During design of hollow shaft, we generally determine or we generally consider the correct inner diameter and the correct outer diameter of the shaft on the basis of strength and rigidity consideration. So here if we consider, here you can see in this diagram, this is the hollow shaft, and here the DO is representing the outer diameter of the shaft, and DI, this is the inner diameter of the shaft. So let us assume C as the ratio of inner diameter of the shaft to the outer diameter of the shaft. Here C, we are considering the ratio of inner to outer diameter of the shaft. Shafts are generally subjected to some axial tensile force, bending moment, torsional moment, or the combination of loads. So here if we consider when the shaft is subjected to axial tensile force, then the tensile stress, what will be the tensile stress? So the sigma T is representing the tensile stress. So this is the formula for the tensile stress on the hollow shaft when it is subjected to axial tensile force. If we put the value of C, that is DI by DO, in that condition the sigma T will be this 4P by pi DO square 1 minus C square. This is the formula for the tensile stress for the hollow shaft. The next condition is when the shaft is subjected to bending moment. In that condition, the bending stress is denoted by, if we are denoting this bending stress by sigma B, so the formula for this bending stress is this, sigma B equal to MB Y by I. See, this is the hollow circular shaft. So in that condition, the I will be this, and the value of Y will be DO by 2, the outer diameter divided by 2. So if we put this value in this formula, we can find out the value of sigma B. So here if we put the value of I and Y, moment of inertia and the distance, so the value or the formula of sigma B will be this 32 MB by pi DOQ in bracket 1 minus C to the power 4. Next condition is when the shaft is subjected to pure torsional moment. In that condition, the formula of torsional shear stress, this tau is denoted as the torsional shear stress. So the tau will be MTR divided by J. So see, this is also for a hollow circular shaft. So here the value or the formula of J, the polar moment of inertia, will be this. The value of R is DO by 2. So if we put the value of J and R in the formula of tau, we can find out the formula of tau. This is the formula of tau. Let us assume when the shaft is subjected to combined bending and torsional moment without any axial force, and in that condition what we will do, we will apply these two theories. maximum principal stress theory and maximum shear stress theory. So if we apply the maximum principal stress theory, in that condition the sigma b will be this, the sigma 1 principal stress will be this. The actual formula for the sigma 1 is sigma b by 2 plus under root of sigma b by 2 square plus tau square. So if we put all the value, the sigma b and the tau, we will get the value of, or we will get the formula for the sigma 1. Similarly, in maximum shear stress theory, if we put the formula of sigma b and the tau, we will get the formula for the tau max or maximum shear stress, or this tau max is also equivalent to 0.5 SYT divided by Fs, factor of safety. Next term is design of hollow shaft on the basis of torsional rigidity. We generally consider the permissible angle of twist per meter length of the shaft in this condition, in the condition of the torsional rigidity. And here theta we are considering or denoting as the permissible angle of twist. So the formula of theta is this, we generally used for design of hollow shaft. This is the formula of theta we are using to design a hollow shaft on the basis of torsional rigidity. I am going to explain a numerical or a small problem related to design of hollow shaft, so you can understand easily the concept of design of hollow shaft. Here is the question. A hollow transmission shaft having inside diameter 0.6 times the outside diameter, which is made of plain carbon steel, and the SYT for this is 380 Newton mm square, and the factor of safety is 3. The a belt pulley 1000 mm in diameter is mounted on the shaft, which overhang the left hand bearing by 250 mm, and the belts are vertical and transmit power to the machine shaft below the pulley. The tension on the tight side and slack side of the belt are 3 kN and 1 kN, while the weight of the pulley is 500 Newton. And the angle of wrap of the belt on the pulley is 180 degree. So calculate the inside and outside diameter of the shaft. So let us discuss how to solve this numerical problem. So here is the diagram. We have a hollow transmission shaft which is having inside diameter 0.6 times the outside diameter. So this is the shaft, this is representing the hollow shaft, and it is having inside diameter is 0.6 times the outside diameter. If we are considering the inside diameter of the shaft is di, so it is 0.6 times of outside diameter. If we are considering di as the inside diameter and do as the outside diameter of the hollow shaft. Here we have the value of yield strength in tension. If we are denoting this yield strength in tension, this is SYT is yield strength in tension. This is 380 Newton per mm square, and we know the yield strength in shear is equal to 0.5 of yield strength in tension. And we have the value of factor of safety 3. We have the value of factor of safety 3, and we have the weight of the pulley. If we are considering W as the weight of the pulley, this is, we have 500 Newton. See, in this diagram, this is the hollow shaft and it is connected by a pulley, and the diameter of the pulley is 1000 mm, and this pulley is connected by a belt, and the another end is overhung. And here we are considering T1 and T2 as the tension in the belt, which is on the pulley. So tension in the belt at the tight side and the slack side. T1 and T2 are the tension in the belt at the tight side and the slack side. This one end is overhang and one end is connected by the pulley, and weight of the pulley is 500 Newton. So if we draw the free body diagram of this shaft, so at this end, at the end of the pulley, the total weight or the total force we will consider as T1 plus T2 plus W. We have the value of tension at the slack side and tension at the tight side. T1 is 3 kilonewton, and we have the value of T2, tension at the slack side, is 1 kilonewton. We have the value of angle of wrap, that is 180 degree. This is the given data, and on the basis of these data we have to find out the inside and outside diameter of this shaft. So for that, first we will find out the permissible shear stress. This is denoted by tau, and the formula for this is SSY, that is yield strength in shear divided by factor of safety. We already have the formula for SSY. This is 0.5 of SYT. SYT is yield strength in tension divided by factor of safety. So this will be 0.5 into 380 divided by the factor of safety is 3. So the value of this will be 63.33 Newton per mm square. This is the value of tau. We are considering the weight of the pulley, so there will be some bending moment always acting on the shaft, and the shaft is in the rotating condition, so there will be some torsional moment also we have to consider. So we have to find out here the torsional and bending moment both. The torsional and bending moment. So first we will find out the torsional moment MT, that is the formula for this T1 minus T2 into R. R is the radius of the pulley. Here we have the value, it is 3 kilonewton minus 1 kilonewton, or we are converting it in Newton, and the value of R is 500 as per given data. So this will be, after calculation, this will be 1000 into 10 to the power 3 Newton mm. This is the value of torsional moment or MT. Now if we want to find out the bending moment MB, so this will be T1 plus T2 plus W. See, this is the shaft, and here we are considering the pulley. So the total reaction or the total force acting at this point will be T1 plus T2 plus W. So the bending moment will be T1 plus T2 plus W into 250. So this will be 3000 plus 1000 plus 500 into 250. So the total value of MB will be 1125 into 10 to the power 3 Newton mm. See, we have the value DI equal to 0.6 of DO. So we can write here C equal to DI by DO. So the value of C is 0.6. And if we apply the maximum shear stress theory, so for that, the value of tau max will be, or the formula for tau max is 16 divided by pi DOQ 1 minus C to the power 4 into MB square plus MT square. And if we put all the values, we can find out the value of DO. We have the value of tau max also, 63.33. 16 divided by pi DOQ 1 minus, where we have the value of C4, that is 0.6 to the power of 4 into, we have the value of MB 1125 into 10 to the power 3, plus we have the value of MT, it is 1000 into 10 to the power 3 whole square. So if we simplify this formula, we can get the value of outer diameter. So value of DO here is 51.81 mm. So from this DO we can find out the value of DI, it is 0.6 of DO. So the value of DI will be 31.09 mm. So this is the value of DO and this is the value of DI for this condition. We can easily, with all these values we can easily draw the bending moment diagram and the torsional moment diagram. Thanks for watching the video and subscribe the channel for more lectures.